Fusion Mobile, quality e-learning experience on the go.
You are once again welcome to our geography class. I believe the subject is getting more interested day by day and topic by topic as we are making progress. This is one of another interesting topic, Earth movement. Earth movement. Earth movement. And some of you begin to wonder now, does Earth move? You know, the first time my geography teacher taught me when I was in SS1, I said the first time my geography teacher taught me when I was in secondary school, some years ago, I told the man that, Oga, how can you tell us that the earth moves? Since I was born, the house of my father, where he built it up till now, the house is still there at the position. So how will you tell us that the earth moves? So the same thing to some of us here. The way we are looking at the topic, it will tell us that, does earth move? Yes, it does. And we are going to look at it. The earth exhibits not even movement, it exhibits two types of movement. Number one, there is what we call rotation. Number two, there is what we call revolution. Remember, in our first topic, we treated the shape of the earth, we treated the earth and other planets, and we also look at the evidences to prove that the earth was not flat but spherical. And if you remember the divination I gave about the solar system, I told us that the solar system comprises the sun and the 9 planets, and these 9 planets, let me emphasize that point again, revolve, move in an elliptical orbit. That is, they move around the sun. And I told us that the sun then takes 365, let me write it, 365, 1/4 days to complete one movement. That is, if the earth starts its movement today round the sun, this is the sun, it will take earth 365 days, 365 1/4 days to do what? To complete one revolution. To complete one revolution, that is movement. Now we talk about rotation. Let us start so that we'll not get ourselves confused. Let's take it one after the other. Number one, let's look at rotation. What do you understand by rotation? Rotation can be defined as the spinning of the earth on its axis. Let me demonstrate it. Can you see this? Can you see this this marker? Can you see? What the marker is doing is spinning. That is what we mean by rotation. The earth spins on its axis. On its axis. And it takes 24 hours to complete one rotation. 24 hours is equals to what? Is equals to 1 day. Why 365 1/4 days is equals to what? Equivalent to 1 year. So earth does rotation as is spinning like this, it is also moving. So it does two movements simultaneously. It's spinning and also is what? Is moving. This spinning of the earth on its axis is what we call rotation. And it takes 24 hours to complete one rotation. While revolution is the revolving of the earth on its orbit, and it takes 365 1/4 days to complete what? To complete one revolution. So rotation and revolution, they are the two types of movement that the earth exhibit. But remember, I told us that these movements are done simultaneously. As the earth is spinning, is also moving. As it's rotating, is also revolving. It will be rotating on its axis and also be revolving on its orbit. We are going to look at the effect of it, the effect of this rotation and revolution. But remember that rotation is within 24 hours, and 24 hours is equals to 1 day, while revolution is within 365 1/4 days. The reason why we have 365 1/4 days is that, remember, I told us that the shape of the earth is like this, and it moves round the sun. Then, if you remember, your little arithmetic will tell you that the angle of a cycle is 360 degree. 360 degree. Now, if you look at the earth like this, and you divide the earth into two, this line is called the equator. We are going to come to that, but let me explain this because of what I'm going to tell us now. This line is called the equator. Equator is a line that divides the earth into two equal halves. From here, this is the north, this is the south. From here to this is called the southern hemisphere, while from here to this is called the northern hemisphere. So this equator that divides the what? The earth into two equal halves. Now, the circumference of the equator, the circumference from here to here of the equator is 40,085. Now, if you divide 40,085 by 360, it's going to give you I think I'll need a calculator. I'll solve this one out. It's going to give you 0.6 degree. 0.6 degree. So by the time you solve it, that 0.6 degree, that is one. If you divide 24 by 6, it will give you what? For 1/4. So if after every year we have 1/4 as a leftover because of this division, the second year we have 365 1/4 again. The third year we have 365 1/4 again. Then the fourth 365. This, it will now be 1/4 plus 1/4 plus 1/4 plus 1/4. Now, your simple arithmetic will tell you, what do? You find the LCM, which is 4. 1 plus 1 plus 1 plus 1, which is 4. 4 divided by 4 is what? 1. Then you add to the fourth year. Instead of 365, it becomes what? 366 years. So days. That fourth year is what we call leap year. Last year, 2016, was a leap year. Instead of 365 1/4 days, what we had last year was 366. So anytime you hear about leap year like we had last year, this year, in the next 3 years to come, we are going to have 365 1/4 days, 365. Then the fourth year, we now add it up together and find the LCM. It will give you 1. That one you add to 365, it will give you what? 366. So instead of that year to be 365, it is going to be what? 366. It is that 366 that we call what? Leap year. So anytime you hear of leap year, remember that the previous 3 years had been 365 1/4, 365 1/4. We are going to look at the effect of rotation and revolution. Remember, when we talk about the shape of the earth, I told us we prove it, And you must have, I say, yes, I think I can understand what this teacher is telling us, that it is true. Now, let's look at what are the effects of the rotation. Effects of the rotation of the earth. Effect. When the earth rotates, what are the effects? What are the effects? Number one, it causes day and what? It causes day and night. It causes day and night. Let me demonstrate it. Can you see? You know, we have established the fact that this is the shape of the earth. This is the north, this is the south. Now, if you have sun here, and we have established that the earth was not flat but what? Spherical. Now, the side that faces the sun, what do? They receive their solar energy, therefore they do what? They have their daylight. So if you have, this is the earth, here will be what? Will be darkness. While this place will be what? Will be light. So it is the rotation. As the earth rotates, as it moves, the side that faces the sun will receive their day, while the side that backs the sun will receive their darkness. The earth will rotate again after some hours, that is 12 hours facing the sun, 12 hours backing the sun. After some time, the 12 hours that back the sun will rotate again and face the sun. The 12 hours that was facing the sun will now back. So like that. That is why I was, explaining when we were discussing the shape of the earth, that some places, as we are talking now in the daytime, people are preparing. People are preparing to do what? To go to bed. Why some people are waking up? I don't know, in economics, I don't know. Let me digress a little. There is what we call overnight lending. Have you ever heard of overnight lending? What happened? At the close of the business in Nigeria, instead of keeping the money in the bank, what do? They transfer this money to people that will be having their own day. So the money did not sleep in the account. The bank is closing, so everything, that money will remain dormant till tomorrow morning. No, that is what we call overnight lending. They lend it out to countries as we are going to bed. They are coming out for their own business transaction. So they lend it. At times it will yield 2%, 3% interest. The following day they collect it back. That is what we mean by overnight. That is to tell us that as we are in the daytime, some people are what? Having their night. And by the time we are going to have our own night, some people will now be emerging from darkness. That is the effect of rotation. Then number 2 is there is what we call down and twilight. Down and twilight. I think some of us, some of you that go to club, they say we are going to dance till down. Have you ever think? What we mean by down is the period between the sunrise. Sorry, let me write it very well. The sunrise and complete daylight. That is what we mean by down. That is between 5:30 a.m. and 6 a.m. in the morning. We call it the down. Then twilight is the opposite of down. Is the period between the sunset and the complete darkness. Maybe around that time. It varies from place to place. It varies. That is why, some of you that are Muslim, some of our Muslim brothers, at times when people from other states will be breaking their fast, some people in other place, they'll still be observing, say the sun is still up, but in some places they have, so it is the effect of the rotation that cause all this. Then number 3, we have differences in time. I've explained that when I was differences in time from place to place, when I was proving that the earth was not a flat but spherical. I gave example of Ghana and Nigeria. Then number 4 effect is deflection. There is what we call deflection of planetary wind. I believe you are jotting down in your notes, so that by the time you want to rehearse what you have learned about the rotation and revolution of the earth, you should know. This one is deflection of planetary wind. What we mean by planetary wind is the wind that blows on the surface of the earth as a planet. We have the one that blows. Remember, let me clean this place very well so that I can demonstrate it again. You know, geography, that is why I said it's not an art subject. Some people, you know, they'll say, no, don't offer geography, don't offer geography, because it's an art subject. From what we have been doing is to tell us that geography is not an art subject. Purely, if they say it's social science, well, we may be tempted to believe, but as we go into detail, we are going to discover that geography is more of science than other aspect of discipline. Now look at it. This is the earth, and I said this is what we call the equator. This is what we call the north. This is what we call the south. Here I say this is the equator, and I told us that from equator to the south we call it what? Southern hemisphere, and from the equator to the north we call it what? Northern hemisphere. So what are we? We say that we are proving trying to explain the deflection of planetary wind. We are talking as the earth moves, the wind that blows from the northern hemisphere, they are deflected to the what? They are deflected to the left. While the wind that moves from the southern hemisphere are deflected to the what? They are deflected to the right. All this is the effect of Earth's rotation, the movement of the Earth. Now, these are the effects of the rotation. Number 1, day and night. Number 2, dawn and twilight. Number 3, sunrise and differences in time at different places. Number 4, deflection of what? Of planetary wind. Now, let's look at the revolution, because at the end of the day you must establish one thing. Number 1, you must know how to define the two terms, rotation and revolution. I've told us what rotation is already. That is the spinning of the earth on its axis, and it completes one rotation in what? In 24 hours. While revolution is the revolving, the movement of the earth around the sun on its what? On its orbit, and it takes 365 1/4 days. And I've explained to us how we get that, and how that 365 1/4, you know, the effect of it. If you combine the 365 1/4, at the end of the fourth year is going to be what? 366, and that is what we call leap year. I've explained to us. Now let's look at revolution. Revolution, as I said, is the movement of the earth on its what? On its orbit. At times they may ask you, differentiate between rotation and revolution. If you have studied the earth's movement, what do you understand by rotation? What do you understand by revolution? Then they will ask you, what are the differences and what are the similarities? These are some of the questions that you need to be, having at the back of your mind, that at the end of this topic you should know what rotation is, you should know what revolution is, and you should know there are differences between rotation either in tabular form or in a paragraph form, and you also know the differences between rotation and revolution. Know their difference, know their similarity. Now let's look at revolution. we have defined revolution. What are the effects of revolution? What are the effects of revolution? Number one, varying, that is some differ. When something differ, it varies. Varying length of day and night. Varying length of day and night. Number two, it determines the year. Number three, it causes season. Causes what? Season. It determines the year. Varying length of day and night. There are at times in some specific parts time of the year, we have the day is longer than the night, and in some specific time of the year, we have the time is shorter, the night is shorter than the day. This is one of the effects of what? Revolution. Number two, it determines the year. We say that the year for the earth to complete one revolution, it takes the earth how many days? Okay, 365, 1/4 days. God bless you. Now the same thing, that 365, 1/4 days, makes what? Makes 1 year. Now it causes seasons. In Nigeria, we have how many seasons? 2. Dry, we have the rainy season and we have what? The dry season. In some other part of the country, like Europe, they have about 4. Some have 6. They have summer, they have autumn, they have spring, and they have winter. But in this part of the world, we have only 2. We have the rainy season or the wet season. Then we have the what? The dry season. So is this revolution of the earth that causes all this? Number one, varying length of day and night. Number two, it determines the year. Number three, it causes seasons. And when we are talking about seasons, it varies from a continent to continent. In the continent of Africa, I think most of the countries, we have 2 seasons, the wet and the dry season. But in other parts of Europe and even Southern America, they have more than 2 seasons. They have autumn, they have summer, they have winter, and what have you. So with this, we are able to establish the fact that the earth moves. Number one, the rotation. Number 2, the revolution. And remember that these 2 movements are not done separately. They are done simultaneously. I've explained to us, as the earth is spinning, is also what? If you can look at this, my marker, as I'm spinning it, is also moving. So the 2 movements happen simultaneously, and we have looked at the effect of it, of both the 2, the rotation and the revolution. Now, what are the difference, or what are the similarities? Number one, let's look at the difference first. What are the difference between rotation and revolution? When you are asked to do it, the simplest way of doing it is what? Provide a table. Said this is rotation, this is what? Revolution. At your level, just provide a table like this, then begin to, and don't allow your points to counteract each other. If, for instance, let's look at one of the we are looking at the differences between what? We are looking at the differences. One of the difference between rotation and revolution is what? Like in number one, rotation takes place within what? How many days? 24 hours. 24 hours. What of revolution? 365, 1/4 what? Days. Can you see? So we are talking about the timing now. Then you come here. This one, it moves on its what? On its axis. Sorry, on its axis. While this one moves on its what? On its orbit. So you see how they goes hand in hand. But if you say you take this one as your number 1 and you come here, you take this one as your number 2, you put yourself in confusion. Number 3, what are the difference again? The difference between rotation and revolution. Who can tell us? Look at the effect very well and tell us the difference between rotation and what? And revolution. Number 1, we say that rotation, the time duration of rotation is 24 hours. While that of what? Now, let's look at number 3. Rotation, it causes day and what? And night. Yes, God bless you. Then, here, it causes what? It causes year. This one is day and night. This one what? It causes what? Year. Now, number 4. Here, differences in what? Differences in time. Then here, what? Differences in season. So if you tabulate your point like this, it will be very clear, and the person that is marking or the teacher that gives you the assignment will now believe that what he has taught you, not only that you understand, but you yourself, you know what you are doing. So the same thing, if it comes to, you know, the similarities. What are the similarities between revolution and rotation, or rotation and revolution, as the case may be? Number 1, both of them, they move around the what? They move around the sun. The 2, the revolution is movement around the sun. The earth, the rotation is also what? Is a movement around the sun. Both of them are movement. So it's one of the what? It's one of the similarity. Now, number 2, when we talk about time, even though the rotation is 24 hours, but revolution also talk about time. What is the time of revolution? 365 1/4 what? Days. It's also, even though it's similarity, but they are talking about the time. They are talking about time. They are talking about time. So these and many more are the similarities and differences between rotation and revolution. Now, this we are going to look at this earth movement. For us to understand it perfectly, we are going to step further to look at some of the lines on the earth. We are going to look at latitude and what? Longitude. Because we cannot complete this topic without talking about these 2 lines, latitude and longitude. When we are talking about latitude and longitude, you know, in the course of my explanation, I've almost explained these 2 words, but this time around we are going to go into detail. Now let's look at the earth again, the shape of the earth. So here I said what? This is what? This is the line of equator. This equator, you know, has other lines parallel to it. They have other lines parallel to it. Now, please, before we even draw the line, let me tell us what is latitude and longitude. They are imaginary lines drawn on the map or on the globe. Imaginary. What we mean by imaginary? You imagine that they exist, but you cannot see them. It's an imaginary line. You know, some of us, we go to church, we go to mosque, you go there to pray to God that you have never seen. But you imagine in your subconscious mind, in your metaphysical mind, you believe that this God exists. Some of us, we dance, we pray, and we even at times bow down. And some of our brothers in other religion, Muslim, they even bow down before this God. There is nobody out of us here can tell us that he has ever seen God face to face. But you believe that this God there, you know, anyhow, you pray, you act as if you are seeing him one-on-one. This is the same thing we are talking here. So when we are talking about latitude and longitude, they are imaginary lines drawn on the map. You don't see them, but you believe that they are there, because by the time you make an attempt to cross either latitude or longitude, something will happen. This is what we are going to discuss. So having known this one run, this is west, this is east, but the line of longitude runs from the north to south. So this is latitude, this is what? Longitude. Now this one we said is called what? Equator. Remember, we are discussing latitude and longitude. Now here is your north pole. This one is the south pole. This line after the north pole is called the Arctic Circle. Then this one is called the Tropic of Cancer. Not cancer as a disease. So then this is what we call the equator. Here we call the Tropic of Capricorn. Now here is called the Antarctic Circle. Then this is the south pole. Remember when I was discussing the shape of the earth, I told us that from this to this we call it the northern hemisphere, while from this to this we call it the what? The southern hemisphere. Now the earth is tilted. The earth does not stand erect the way I'm standing. I think you can see me. I'm standing erect. But what the earth does is that it's tilted, it's bent. And it bends at an angle. Here we have 23. 1/2 degree. Here is 66. 1/2. This is 0. The same 66. 1/2. The same 23. 1/2. This is 90 degree. This is 90 degree. So then this line that divides the earth into two equal halves, that is the west and the east, we call it the Greenwich Mean Time. That is, have you ever heard of GMT? Say GMT. I know you've heard of it. Some of you, you watch football a lot. So whenever they are talking 800 GMT, 1000 G or 10-hour GMT and so on. Now this line I've told us when I was describing the time difference. Here we have Ghana. This is the center of the earth, and we also have Britain. These two countries have the correct perfect time. So all other countries, either you are the west or you are the east, you adjust your time to these two countries. I'm explaining to us because of this thing we are discussing, latitude and longitude. So these two countries have the perfect time, Ghana and Britain. So if you are the east, like Nigeria, we are located at the east. That is why we are 1 hour ahead of Ghana. So if there is a football match between Ghana and Nigeria, and it's going to take place the local time of Ghana, maybe by 5 p.m., when it was Nigeria going to watch the same match, because we are 1 hour ahead, we are going to watch the same match at 6 p.m. So we use this longitude and latitude to do what? To calculate time difference. To calculate what? Time difference. So I've just given us a simple explanation of Ghana, because the closest country to us here is Ghana. So if a football between Super Eagles of Nigeria and the Black Stars of Ghana is going to take place in Ghana by 5 o'clock in their own local time, because we are 1 hour, Nigeria is located at longitude 15 degree east. So we are 15 degrees equals to 1 hour. Now we are 1 hour ahead, the same match but at different time. While in Ghana their local time is 5 o'clock, in Nigeria the same match, we are watching it at a different time. So when we talk about longitude, it's used to calculate time. Then when we talk about latitude, it is used to calculate distance on the map. Now, longitude is for time, latitude is for distance. For instance, here if we have maybe, I'm citing an example. Let's say Egypt is here, and Nigeria is here. Then they will ask you, what is the distance in kilometer? If Egypt is located on latitude maybe 30 degrees south, and Nigeria is located on latitude maybe 45 degrees north, there is a formula. We are going to do one just simple is arithmetic, just simple of this, so that you know how to calculate. So what I'm saying is that latitude we use to calculate distance, and longitude we use to calculate that time difference. So when you have the knowledge of longitude and latitude, it gives you a kind of that is why geography is very lively. Geography is very lively because if there is a match, I think next month there will be a match, or in the next 2 months there will be a match between Nigeria, I think South Africa. I don't know where it's going to be played anyway. If it is in South Africa, the best thing as a geography student, find out the longitude of the longitude of geography. The longitude of South Africa. Find out where South Africa is located. Look at the time and look at the longitude of Nigeria. Before you know when to tune in either your television or your radio to listen to the live commentary of the same match going on over there in South Africa and here in Nigeria. But in the case of latitude, as we said, I'm going to give us one example of how to use latitude to calculate distance on the map. And I want you to be very, very, very attentive, because after this it's very simple, but you have to know some little secrets, so to say. Now let me draw this again, in case this is the shape of the earth. We have all agreed that this is the shape of the earth. Now here is the equator. From here is the north, from here is the south. I said here we call it the southern hemisphere, and here we call the northern hemisphere. All this line, lest I forget, the Arctic Circle, the Tropic of Cancer, the Tropic of Capricorn, and the Antarctic Circle, they are called the parallel of equator. They are parallel. This is the equator, latitude 0. All these lines, they are also called parallel. Another name apart from latitude is called what? Parallel of equator, because they are parallel to what? To the equator. Now I want to solve one little arithmetics. But before I do that, let me give us the formula. In using latitude to calculate time, there are things you must know. Look at here, this is the equator. The equator, as I said, divide the earth into two equal parts. From equator to the north is the northern hemisphere, down to the south is southern hemisphere. Now what do we do here? If we have two locations in one hemisphere, for instance, if we have a point 0.5 degree north and maybe 16 degree north, what we do is that we subtract 5 from 16. That is, let me write so that you get what I'm saying very well. Let me give you this simple formula. If the direction is north, what you do, you subtract. That is, you minus. The same thing, if it is south, you do what? You subtract. But when it is north and south, you are going to do what? You are going to add. You are going to add. Now, when we're discussing the 365 1/4 days, I was telling us that I'll do now. I now remember perfectly. Now the circumference of the equator here is 40,085. That is the cycle. The angle of a cycle is what? Is 360. If you divide this by 360, it's going to give you 1 point something. That is 0.6. So that shows that the distance between one latitude and the other is equals to 111 kilometers. Remember, we are discussing what? The distance, measurement of distance on the globe, and distance, normally is measured in kilometer. So if you divide 40,085 over as the circumference of the equator, it will give you over 360. It will give you 111.6 something. Now, that's to tell us that between one latitude and the other, the distance is 111. Let me repeat myself again. If you are calculating a distance between 2 points in the same direction, that is north and north, what are you going to do? You are going to subtract. If it is south and south, you are going to also subtract. But if it is north and south, you are going to add. Then you multiply by the distance of the equator from of the line of the parallel of equator from each other. Let us solve one example so that maybe you get what I'm saying very well. Remember these 3 steps. North, you subtract. South, you subtract. North and south, you do what? You add. Now let us look at this. We are going to use examples to prove how to calculate distance on the map using the lines of latitude. And let me emphasize this again. When I was explaining to us these 2 lines, we have the equator. We call it the equator. Then here we call it GMT. Some people called Greenwich Meridian time, but others called Greenwich Mean Time. Any of the 2 is correct. In case maybe some of us that want to make inquiry, you can take a look at your textbook. It's either they are talking about Greenwich meridian or Greenwich mean time. Any one is correct. But let's come to what we are doing here. Here we have the line of latitude, as I explained to us. Now let me set this or write this question down. What is the distance? What is the distance between Egypt, latitude 30° south, 30° south, and Spain, latitude 65° south. Let me repeat again. What is the distance between Egypt, latitude 30° south, and Spain, latitude 65° south? Look at here. South, south. What do? You subtract. If you subtract 30 from 65, it will give you what? 35 degree. That is 30. You take it away from what? 65. It will give you 35 degree. Then you multiply this 35 by 111. This 35 multiplied by 111 will give you whatsoever it gives you. It will be in kilometer. So the distance between Egypt and what? And Spain, whatsoever 35 multiplied by 101 kilometer gives you, is the answer. But if on the other way around, Egypt is not here, Egypt is not here, this is Egypt is here, 30° north, and Spain is what? 65° what? South. You come here, north and south. What do? You add 30 plus 65 degree. What will it give you? It will give you what? 95. Now 95 multiplied by 111, whatsoever it gives you in kilometer, will be the distance between Spain and Egypt. So what we have achieved here is this. If you are given a calculation using latitude to calculate the distance between 2 points or 2 countries or 2 villages or 2 features on the map, remember, or on the globe, sorry, not on the map, on the globe, you should know this. The location, is it at the north? The 2 locations, are they in the same hemisphere? This is equator, this is north. Is it north north? Is it south south? If it is north north, you subtract the smaller one from the smaller number from the bigger number. You multiply by 111. If it is south south, the same thing. But if you have different direction, that is, you have north and you have south, what you do is that you add 30 plus 65. It will give you 95. 95 multiplied by 111, then whatsoever it gives you will be the distance between Egypt and what? And Spain. And I've explained to us how we get this 111. I've explained again, because this is some little mathematics that most of the time, some of us, it will put us into confusion. Maybe when you get home, you want to practice it on your own. Remember, we said that this is the equator. We are using latitude. Latitude is used to calculate distance, while longitude is used to do what? To calculate time. So if you are using that, you must know the standard distance between one latitude and the other. To know that, you know the circumference of the equator. is established as 40,085. Then circumference, that is cycle. The angle of a cycle is what? 360. Divide this by 360. It will give you 111 point something, 0.6. So we are making use of this 111. That is why we are using 111. So in your calculation, 111 is the standard, is the as 360 degrees equals to an angle of a cycle. So also is this. The distance between one latitude and the other is 111. So it's a standard one. You can use it either to calculate distance on the map, on the globe, between 2 points at different hemisphere, either north or south, then the same hemisphere, north or south. So with this, we know that we have discussed the line of latitude and longitude. Then finally, before we close this topic, this line, I've explained again, this line is called what? It's either you call it the international date line. International date line, because if you are coming from the east and you cross this line, you know, something, it will either you lose 24 hours or you gain 24 hours, depending on where you are going. So we call it the great cycle. So on the map, on the globe, we have equator is also a great cycle. We have this line, 180 degree, is called the great cycle, or we call it international date line, the way you want to call it. So because once you cross it, either towards the east, and this is your west, towards the west you are going to lose time, towards the east it depends on the direction you are going. So let us have this at the back of our mind. So with this, we have studied, who can remind us again the topic? We have studied the shape of the earth. We have studied the evidence to prove that the earth is spherical. We have studied the what? The earth movement. And we have how many movement? 2. The rotation and the what? The revolution. And these two movements, what do? It happens simultaneously. And we say that we have similarities and we have what? Differences. So if you are talking about rotation and revolution, what are the differences? What are the similarities? Then I told us that if you are asked to, explain or give the difference between rotation and revolution, or mention the difference between rotation and revolution, what, as a student, what you should do is that you should put it in a tabular form. It will give you a sense of belonging. This place may be revolution, this place may be what? Rotation. Then you take your point one after the other. After that, we went ahead to look at the important lines on the globe. Number 1 is latitude, number 2 is longitude. And we say that these lines, they are imaginary, you don't see them. You don't see them. So you will not say, okay, when I get out of the class, let me go and look for the line that the teacher was talking in the class. No. I gave us an example of some of us that go to church, some of us that go to mosque, even some of us that even we are free thinker. But you must believe something. So you believe that this thing exists. This being exists, whether knowingly or unknowingly. So the same way you believe God exists, believe that the line of longitude and latitude exists. And what do we use? What are their uses? We use the line of longitude to calculate time difference. I gave us example of Ghana and Nigeria. Nigeria is located at longitude 15 degree east, while Ghana is located at longitude 0. I told us why it was so. So the difference between the time in Ghana and that time of Nigeria is 1 hour. So Nigeria is 1 hour ahead of what? Of Ghana. Then when we talk about latitude, we are talking about the distance in kilometer between 2 points on the globe, where we gave example of Spain and Egypt here. Then before we solve that, we say that if you have a distance on the same direction, on the same sphere, that is from the equator to the north, this is northern hemisphere, that is north-north. What do? You subtract. If it is from equator to the south, you have the 2 points. What do? You subtract. But if it is north and south, what do? You add and multiply by what? By 111. And I've told us how we get this 111. The circumference of the earth is 40,085. Then the angle of a cycle is 360. If you divide this by this, it will give you 111.6 something. So we established our fact that the distance between one latitude and the other is 111. So when you subtract or add, depending on the direction you will multiply, it will now give you the distance between 2 points on the globe. So with this, we are done with latitude and longitude.